Hello, let's take a look at your MT2 or MT6 LT2 seminar. Uh, we're going to continue to prove theorems about lines and angles and triangles. We're going to model with mathematics, we're going to use some tools, and we're going to tend to precision. Uh, the content we're going to use that for is to prove theorems and solve problems about angle bisectors. We did perpendicular bisectors in the previous lesson. Now we're going to look at angle bisectors. And we're going to prove theorems and apply geometric methods to solve design problems using angle bisectors. Now, we have two theorems we're going to look at here. Let me make this bigger for us. And an angle bisector. Notice on this problem, we've got the segment BF. It's bisecting angle B. So we got these two angles that are congruent. Notice we also have some right angles here. We're given that. Notice in these two triangles, we've got two angles that are congruent. And then side BF by reflexive. So I've got angle, angle, side. And so therefore by angle, angle, side, those two triangles are congruent. And by CP, CTC, we know DF is congruent to FE. So we're saying any point that is on this angle bisector is going to be the same distance from side. And remember from chapter 3, distance is measured at a right angle. That's how we know they're right angles. Now let's take a look at the converse of that. And the converse says, hey, if I've got a point that is the same distance from both sides of an angle, then that point is on my angle bisector. So that's what we're saying here. Notice I've got FD and FE, they're congruent, and I've got a right angle. And I always like to include my angle on the inside here. And just like on the last problem, BF is congruent to itself. So I've got a right triangle, I've got hypotenuse leg. Because I've got hypotenuse leg, that means these two triangles are congruent. And because these two triangles are congruent by CPCTC, I know FBE and DBF, they're going to be the same. You're going to do these proofs on your assignment. That's why I'm going over them. Now, just to apply it, whoops, I got a little extra segment there. Notice on this first example, we're supposed to find QT. The first thing I notice is I got an angle bisector, don't I? I'm cutting this angle in half. Since I got an angle bisector, I know my distance from each side are the same. In other words, 4x plus 8 equals 9x minus 7. And now we'll just do the algebra to solve that. Let's subtract 4x from both sides. I'd like to subtract a smaller one. At the same time, let's add 7 to both sides. So 15 equals to 5x. Divide by 5. And x is 3. But I want to find q to t. So I'm going to say 4x plus 8. And so we're going to say 4 times 3 plus 8. Or 12 plus 8 is 20. And that's going to equal to q to t. Don't forget to substitute those back in on some of those problems. Now, applying our converse that we just learned, notice on this problem, my two lengths, 5s, they're the same distance. So I know WX is the same distance from WZ. I know its distance because I've got a right angle here, don't I? Which means YW is an angle bisector. Since YW is an angle bisector, this gets to be 38 degrees. And there's your answer. And that's all they were asking on that one. Now we have an in-center. Remember, on the previous lesson, when you got perpendicular bisectors, you had the circumcenter. If I have angle bisectors, I have an in-center. I remember this because they both start with vowels. So I always remember in-center goes with angle bisector. If I take a look at a construction here that we did on the computer, I've got my angle bisectors. Notice I'm bisecting angle A, angle B, and angle C. They intersect at point D is what we call the in-center. And the in-center is the same distance from all your sides. Notice D to K, D to J, and D to I are the same. In an in-center, they're the same distance from the sides. When we did yesterday, the circumcenter was the same distance from your vertices. And notice it's called an in-center because it's the center of the inscribed circle. My circle is on the inside of my triangle. Perpendicular bisectors are on the outside. So we want to compare and contrast those. And we're going to be doing that on your assignment. Most of your assignment is going to deal with in-centers because it's new. But we're also going to do some perpendicular bisectors so you can compare and contrast how we approach those differently. And we'll go through that in the next video because this is getting kind of long already.